Hello everyone. We'd like, on behalf of the factory, I'd like to welcome you, a warm welcome to the Nordic Roaster Forum 2014. It's great to see all these known faces and experts and great coffee people in the same room. Thank you very much for coming. It's really nice. We have put this together for you. The organizing committee, right behind me, consists of Jens Nørgaard, and Tim Vendelbo, Morten Mølkau, and myself, Jens Thompson. So we started this little operation with the factory about a couple of months ago. We've been quite busy and we're so happy to have you here. Welcome to all of you. Thank you very much. Morten is going to give a little bit of housekeeping information about how the whole lecture and cupping works, more or less, toilets, etc. So, Morten?
Yes. Okay, but great to see you all. Today is going to be a pretty packed day in terms of information and logistics. So I just want to give you a picture of where we will be in the different parts of the day. So every time there's a lecture, it's in here. And every time there's a cupping or some practical stuff, it's in the factory room that I'm sure you've all been to. So those are the two rooms we'll be in. And as you might have noticed, it's not really big, and we're going to be 60 people in there. So please make sure to be aware of making everything running as smooth as possible in there by being attentive to what you are told to do, and just be attentive to making everything work. You are all, or you will be given a cupping spoon as a gift, but also to use during the cupping sessions. You will also get a Wilfer pour-over. Actually, I don't know exactly when you will get it, but I think it will be in there. End of today, okay. And just practically, you've got 2 toilets in here, and that's in the end of the room, a little red door, and you'll find the 2 toilets just inside. And in the factory, there's a small toilet. I don't know how to describe where it is, but there is a toilet, so just ask for it if you're in need. And it's nice and big. Okay, great. All right, but I guess then the program starts. And by coincidence, the first speaker is me. So I'll just find the slide. And remember the last thing I need to tell you. We're going to do a cupping session, 11:30. And this cupping session is pretty unique in that we use some advanced statistics. And in order to use some advanced statistics and be able to show you the result in the end of the day, we need to capture the data digitally, because we don't have time to fill out 60 handwritten forms. So we need you to go in here and register yourself with your email address, and there are also some other information. Some of them are serious, some are more fun, but we need you to fill out this and give your email address so that you can get a unique email later on, so that your data can be captured. So please go here and fill out. How many of you didn't do this? Okay, it's really important that you do this way before 11:30. This code, it is basically just to go to this link, and we also have some printouts on the tables. So please go and sign up as the first thing when you leave from this lecture. To make this work with Wi-Fi, you can sign up using the Wi-Fi in here. There's a blackboard in front of the entrance to this room, where you can see the Wi-Fi name and the Wi-Fi code. When we go to the factory, there's not an internet connection able to take all the data. So we will ask all the Europeans here to just roam, because that's not that expensive anymore. And then we will have Wi-Fi for the non-Europeans, okay? But we'll come back to that. All right. So today is going to be pretty scientific in different aspects. So I don't know if you saw the program, but after me, Professor Wenda Bredi will tell you something about Maillard chemistry. But I felt that I should just give you a short introduction to put Wenda's presentation into context. So I've just made this short presentation for you that I'll show you, because it's coffee chemistry is not a small subject. So I just thought that I'll give you a soft landing. I just want to mention shortly who I am for those of you who don't know me. My name is Morten Münchow. I own the company Coffee Mind, and that is a training, consultancy and research company. I started all these activities in 2007. And at the moment, I'm pretty involved with the SCAE, because I've been teaching coffee roasting at London School of Coffee for 7 years. So I've developed my own teaching strategy with regards to entry-level coffee training and advanced. And I have then created the certification system for SCAE, the new 3-level CDS system. SCAE has also, from this July, started to pay me a part-time salary to do research project at the University of Copenhagen. And we've already done actually 7 since November, so the first 6 months were for free. We are going to do a lot of research that takes a point of departure, all the questions that the specialty coffee business has, because most of the research questions and most of the research from the commodity business is simply not relevant or really difficult to extrapolate to specialty coffee or high quality questions. So every time, and I'm sure you've done that, you try to read some article, then you are just left with, well, how can I apply this, or how is this relevant to my problems? And so we're going to take all these questions that you have, and then we're going to formulate them into research questions, and then the idea is that we get a lot of master's thesis students to start off trying to solve this, or at least answer the question satisfactorily, so that we can get a next step. The project that will be mentioned today before and during Wenda's presentation is a good example of what can be done. Yeah, and I started at Contra Coffee in 2005, and that's what started everything for me. And I just want to make sure to mention that everything I've done today is done in their premises and on their machines, with a lot of help from the staff at Contra, providing everything I needed. Okay, I think that was it. So I'll just jump straight into the chemistry. So coffee is an organic substance, and an organic substance is a substance that's primarily composed of carbon. And you can see the red element in the periodic table of the element in this chart is carbon. So organic molecules has got carbon as its backbones. And then, so you have different kinds of molecules. Organic molecules are big clusters of carbon atom connected together, and then with some other minor atoms at different sites. And that's all the yellow ones you can see up there. Do we have a laser pointer? Bender has got one. Great, thanks a lot. Thank you. Great. Okay, so I hope you remember this from physics. So we are going to talk about carbon and carbon molecules. And in coffee, the main constituent of coffee is cellulose. It's a long molecule consisting of glucose sub-units, just connected in long chains. And glucose, as you can see, is this one. It's a 6 carbohydrate with this particular shape. And when talking about sugars in coffee, it's important, of course sugar gives sweetness, but sugars are also feeding the aromatic reactions, because sugar is what gives you the brown and coffee-specific aromatic aroma, or actually it's not specific for coffee, because this brown reaction is the crust of bread, and everywhere you've got food substances heated to 150 degrees, you will get this brown reaction. But green coffee doesn't taste anything like roasted coffee, so the Maillard reaction is the main reaction that gives you the coffee flavor. And it's important to think that sugar is not just enough that you've got a lot of these cellulose. 50% of green coffee consists of cellulose. So you would think, oh, then you can have a lot of Maillard reaction. Well, you can, but that's not because of the cellulose. That's because you've got sugars in this form. It's not even enough to have it in the closed ring, but you need to open up the sugar, and this will happen spontaneously. So you need the sugar in this state before it's able to feed into the Maillard reaction. So that was just to give you an idea about sugars, the different shapes of sugars and different connections, and what is needed in order to go into the Maillard reaction. And this is called a reducing